Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You are managing a few hundred Ubuntu and Red Hat Enterprise Linux virtual machines running on Google Compute Engine, GCE. You need to patch the operating systems for those VMs periodically in a secure and scalable way. What should you do? The options are: Option A, create a cloud scheduler job to run a bash script that securely connects to each VM and applies the patches. Option B, configure config sync and install the ops agent on each VM. Schedule a patch job to apply patches on each VM. Option C, schedule a cloud build job and use Cloud Deploy to run a patch job that applies patches on each VM. Option D, set up VM Manager and install the OS config agent on each VM. Schedule a patch job to apply patches on each VM.
To arrive at the correct answer, we focus on the keywords Google Compute Engine, GCE, patch the operating systems for those VMs periodically, secure and scalable.
The correct answer is Option D, set up VM Manager and install the OS config agent on each VM. Schedule a patch job to apply patches on each VM.
Why is this correct? D. The VM Manager, alongside the OS config agent, is Google Cloud's native tool for automated, scalable, and secure OS patch management across fleets of Compute Engine VMs. Why are the others incorrect? A. Cloud Scheduler with custom bash scripts creates excessive maintenance overhead and lacks scalable, centralized compliance tracking for OS patch management. B. Config sync is used for Kubernetes configuration management, and ops agent collects telemetry, logging/metrics, neither of which performs OS patching. C. Cloud build and cloud deploy are continuous integration and deployment, CI/CD, services meant for software delivery, not OS patching for GCE instances.
Your company uses Salesforce for Customer Relationship Management, CRM, ServiceNow for IT Service Management, and a Cloud SQL database to store customer transaction data. You need to seamlessly connect, map, and transform data between these systems to ensure data consistency and enable real-time reporting. You want to follow Google recommended practices. What should you do? The options are: Option A, leverage workflows to connect the services and transform the data. Option B, leverage application integration to connect the services and transform the data. Option C, leverage pub/sub and BigQuery to connect the services and transform the data. Option D, leverage pub/sub and DataStream to connect the services and transform the data.
To arrive at the correct answer, we focus on the keywords Salesforce, ServiceNow, Cloud SQL, connect, map, and transform data between these systems, Google recommended practices.
The correct answer is Option B, leverage application integration to connect the services and transform the data.
Why is this correct? B. Application integration is Google Cloud's IPaaS solution specifically built to connect, map, and transform data between enterprise SaaS applications like Salesforce and ServiceNow and GCP services. Why are the others incorrect? A. Workflows orchestrates serverless workflows and HTTP endpoints, but lacks pre-built enterprise SaaS connectors and built-in data mapping tools for Salesforce and ServiceNow. C. Pub/sub handles messaging and BigQuery handles analytics data warehousing, but neither offers pre-built connectors or data mapping between third-party SaaS applications. D. DataStream provides change data capture, CDC, for databases, not data mapping, transformation, or integration between SaaS applications like Salesforce and ServiceNow.
You are designing the architecture for a global social media site on Google Cloud. The site serves dynamic API content, static assets such as CSS, JS, images, and user-uploaded videos for streaming. You need to minimize latency for all content types for users worldwide. What should you do? Choose 2. The options are: Option A, use an external application load balancer to serve your application APIs. Option B, use Cloud CDN to serve static assets of your application. Option C, use Media CDN to serve static assets of your application. Option D, use Memory Store to serve your web application. Option E, use a multi-region cloud storage bucket to serve your entire web application.
To arrive at the correct answer, we focus on the keywords: dynamic API content, static assets, minimize latency for all content types for users worldwide. Choose 2.
The correct answers are Option A, use an external application load balancer to serve your application APIs. And Option B, use Cloud CDN to serve static assets of your application.
Why is this correct? A. External application load balancer routes global HTTP/S traffic over Google's Premium Edge network, providing low-latency Anycast routing and SSL termination for dynamic API requests worldwide. B. Cloud CDN integrates directly with external application load balancers to cache web static assets like CSS, JS, and images at global edge locations close to end users, minimizing latency. Why are the others incorrect? C. Media CDN is optimized specifically for large-scale video streaming and file downloads, whereas Cloud CDN is the standard choice for general web static assets like CSS, JS, and images. D. Memory Store is an in-memory Redis/Memcached cache for backend data and session management, not a web server or proxy for serving front-end web applications. E. Cloud storage alone cannot execute dynamic API logic and lacks global edge caching features required to serve an entire web application with low latency.
You are creating a migration plan to move your organization's infrastructure from on-premises to Google Cloud. You want to understand and manage costs effectively after the migration is complete. Which strategies should you include in the migration plan? Choose 2. The options are: Option A, enable backup and DR service. Option B, configure labels and tags for the resources provisioned in Google Cloud. Option C, create a Cloud Scheduler job to export billing data to Cloud SQL. Option D, create service alerts using cloud monitoring. Option E, adopt infrastructure as code (IAC) for the cloud resources.
To arrive at the correct answer, we focus on the keywords: migration plan, understand and manage costs effectively. Choose 2.
The correct answers are Option B, configure labels and tags for the resources provisioned in Google Cloud. And Option E, adopt infrastructure as code (IAC) for the cloud resources.
Why is this correct? B. Configuring labels and tags allows organizations to categorize, track, and attribute Google Cloud resource usage and costs accurately across departments and projects. E. Adopting infrastructure as code (IAC) standardizes resource provisioning, prevents configuration drift, enables cost estimation prior to deployment, and simplifies decommissioning unused resources. Why are the others incorrect? A. Backup and DR service provides data protection and disaster recovery management, which adds operational costs rather than helping track or manage overall infrastructure expenditure. C. Google Cloud natively exports billing data directly to BigQuery for detailed cost analysis, making a Cloud Scheduler job to Cloud SQL unnecessary and inefficient. D. Cloud monitoring service alerts track system performance and resource health, whereas cloud billing budget alerts are used for cost and expenditure management.
A Cloud Run service running your serverless application is unable to connect to an AlloyDB database created with default configurations. You need to troubleshoot and resolve the issue as quickly as possible. What should you do? The options are: Option A, verify that the Cloud Run service and AlloyDB instance are in the same region. Option B, enable direct VPC egress for the Cloud Run service and send traffic directly to a VPC. Option C, disable the default public IP address of the AlloyDB instance and use the private IP address in the connection string. Option D, create a Cloud SQL instance, and migrate the AlloyDB database to PostgreSQL on Cloud SQL.
To arrive at the correct answer, we focus on the keywords: Cloud Run Service, unable to connect to an AlloyDB database, default configurations.
The correct answer is option B. Enable direct VPC egress for the Cloud Run service, and send traffic directly to a VPC.
Why is this correct? B. AlloyDB instances use private IP addresses by default and are not publicly accessible. Cloud Run requires direct VPC egress to route outbound traffic directly into the VPC network where AlloyDB resides, allowing the serverless application to establish a connection. Why are the others incorrect? A. Being in different regions does not block network reachability if VPC routing exists, nor does aligning regions grant Cloud Run access to the private VPC network where AlloyDB resides. C. AlloyDB instances are created with private IP addresses by default and do not have a default public IP. Disabling a non-existent public IP does not grant Cloud Run network access to the VPC. D. Migrating the database to Cloud SQL PostgreSQL is an unnecessary, disruptive architectural change that does not resolve the underlying lack of VPC network egress from Cloud Run.
Your company is building containerized applications as part of their CI/CD pipeline. To improve the security and maintainability of the build process, you need to identify potential vulnerabilities within your container images, generate verifiable metadata about the builds for auditing and compliance. Create a comprehensive inventory of your application's dependencies. What should you do? The options are: Option A. Use Cloud Build to build container images, and then trigger artifact analysis on images pushed to Artifact Registry. Option B. Use Cloud Build to build container images, trigger binary authorization, and use Cloud Asset Inventory for tracking and analysis. Option C. Use Cloud Build to build container images, push the images to Artifact Registry, and use Security Command Center for tracking and analysis. Option D. Use Cloud Build to build container images, trigger binary authorization, and use Security Command Center for tracking and analysis.
To arrive at the correct answer, we focus on the keywords: containerized applications, identify potential vulnerabilities within your container images, generate verifiable metadata about the builds for auditing and compliance, create a comprehensive inventory of your application's dependencies.
The correct answer is option A. Use Cloud Build to build container images, and then trigger artifact analysis on images pushed to Artifact Registry.
Why is this correct? A. Artifact analysis integrates directly with Artifact Registry to scan container images for vulnerabilities, generate verifiable build provenance metadata, and create a comprehensive software bill of materials (SBOM) dependency inventory for auditing and compliance. Why are the others incorrect? B. Binary authorization enforces deploy time signature policies rather than scanning image vulnerabilities or generating build metadata. Cloud Asset Inventory tracks GCP resource configurations, not container image vulnerabilities or dependency spams. C. Security Command Center provides centralized threat detection and security posture management, but it does not natively scan container images for vulnerabilities, generate build provenance metadata, or create software dependency inventories. D. Binary authorization validates signatures during deployment, while Security Command Center monitors overall cloud security posture. Neither service performs image vulnerability scanning, generates build metadata, or creates dependency inventories.
Your team is running applications on a Google Kubernetes Engine (GKE) cluster with a private endpoint. You've set up a cloud deploy pipeline, but deployments to the GKE cluster are failing. You need to resolve the issue. What should you do? The options are: Option A. Use VPC service controls with Cloud Build. Update the cloud pipeline to use Cloud Build as its execution environment. Option B. Create a Cloud Build private pool in the default VPC. Use Cloud Build to deploy the applications to the GKE cluster. Option C. Create a Cloud Build private pool that is paired with the same VPC network as your GKE cluster. update the Cloud Deploy pipeline to use this private pool as its execution environment. Option D. Create a custom target in Cloud Deploy. Update the deploy pipeline to use the custom target for the application deployment.
To arrive at the correct answer, we focus on the keywords Google Kubernetes Engine, GKE, cluster with a private endpoint, Cloud Deploy pipeline. Deployments to the GKE cluster are failing.
The correct answer is option C. Create a cloud-built private pool that is paired with the same VPC network as your GKE cluster. Update the Cloud Deploy pipeline to use this private pool as its execution environment.
Why is this correct? C. GKE private clusters restrict control plane access to internal IP addresses. Cloud Deploy defaults to public cloud build workers, which cannot reach private endpoints. Creating a cloud build private pool paired with the cluster's VPC network enables direct private network connectivity for application deployments. Why are the others incorrect? A. VPC service controls create security perimeters for Google Cloud services but do not provide VPC network connectivity. Using Cloud Build without a private pool paired to the GKE cluster's VPC network will not resolve the inability to reach the private GKE control plane. B. Creating a private pool in the default VPC does not automatically grant access to the GKE cluster's specific VPC network. The private pool must be paired with the exact VPC network hosting the private GKE cluster endpoint to establish network communication. D. Custom targets in Cloud Deploy enable deployments to target types outside standard GKE or Cloud Run services. Creating a custom target does not address or fix underlying network routing issues between Cloud Build workers and a private GKE control plane endpoint.
You are planning to migrate your on-premises compute and SAP workloads to Google Cloud. You want to follow Google recommended practices to quickly create a cost estimate for running these workloads in Google Cloud. What should you do? The options are: Option A. Leverage Cloud Asset Inventory to gather data and generate a cost estimate. Option B. Use the Google Cloud Pricing Calculator and input the estimated resource to generate a cost estimate. Option C. Engage with a Google Cloud partner to perform a comprehensive assessment and provide a customized cost estimate. Option D. Gather data about your current environment and leverage Google Cloud Migration Center to generate a cost estimate.
To arrive at the correct answer, we focus on the keywords on-premises compute and SAP workloads, Google recommended practices, quickly create a cost estimate.
The correct answer is option D. Gather data about your current environment and leverage Google Cloud Migration Center to generate a cost estimate.
Why is this correct? D. Google Cloud Migration Center is Google's recommended unified migration platform that discovers on-premises infrastructure and specialized SAP workloads to quickly generate accurate TCO and cost estimates. Why are the others incorrect? A. Cloud Asset Inventory manages and analyzes existing Google Cloud resource metadata, not on-premises infrastructure or workloads for migration cost estimation. B. The Google Cloud Pricing Calculator requires manual resource inputs rather than automatically importing or analyzing on-premises environment data for quick migration cost estimation. C. Engaging a partner is a consulting service process rather than using Google's recommended automated tooling to quickly generate self-service cost estimates.
Your organization has a significant amount of log data stored in cloud logging. The data engineering team is accustomed to using SQL for analysis and wants the ability to create insightful dashboards for visualizing log trends and patterns. You want to follow the recommendations of the Google Cloud Well-Architected Framework to provide a solution for the data engineering team. What should you do? The options are: Option A. Create a log sync and export the data to BigQuery using pub/sub. Run queries and visualize the data with cloud monitoring dashboards. Option B. Enable log analytics and run queries in cloud monitoring. Visualize the data using Vertex AI Workbench. Option C. Enable log analytics and run queries in the linked log dataset in BigQuery. Visualize the data with Looker Studio dashboards. Option D. Create a log sync and export the data to a storage bucket. Create an external table in BigQuery for the data in the bucket. Run queries and visualize the data with cloud monitoring dashboards.
To arrive at the correct answer, we focus on the keywords, cloud logging, accustomed to using SQL for analysis, dashboards for visualizing log trends and patterns, Google Cloud well-architected framework.
The correct answer is option C. Enable log analytics and run queries in the linked log dataset in BigQuery. Visualize the data with Looker Studio dashboards.
Why is this correct? C. Enabling log analytics on a cloud logging bucket creates a linked BigQuery dataset. This allows running SQL queries directly on log data and connecting to Looker Studio for insightful dashboard visualization, aligning with Google Cloud well-architected best practices. Why are the others incorrect? A. Routing log data through pub/sub to BigQuery adds unnecessary complexity compared to native log analytics. Furthermore, cloud monitoring dashboards cannot visualize BigQuery SQL query results. B. Cloud monitoring is intended for metrics rather than executing BigQuery SQL queries. Vertex AI Workbench is designed for data science and machine learning workflows, not dashboard visualization. D. Exporting logs to cloud storage and creating external BigQuery tables introduces operational overhead compared to log analytics. In addition, cloud monitoring dashboards do not support visualizing BigQuery SQL query outputs.
You are designing the storage architecture for a financial analytics platform. The platform ingests and stores terabytes of transactional data daily, which is used for both real-time fraud detection and long-term historical analysis. Transaction data from the last 30 days must be accessible with very low latency for the fraud detection engine. Data older than 30 days is accessed infrequently for quarterly reports, where retrieval times of a few seconds are acceptable. All data must be retained for 5 years to meet compliance regulations. You need to design a solution as cost-effective as possible. What should you do? The options are: Option A. Store all transaction data in a cloud storage bucket using the standard storage class for the entire 5-year retention period. Option B. Ingest all data into BigQuery using time partition tables, and rely on BigQuery's automatic long-term storage pricing for data older than 90 days. Option C. Configure a cloud storage bucket with an object lifecycle management policy to transition data from the standard class to the archive class after 30 days. Option D. Configure a cloud storage bucket with an object lifecycle management policy to transition data from the standard class to the cold line class after 30 days.
To arrive at the correct answer, we focus on the keywords, very low latency, data older than 30 days is accessed infrequently for quarterly reports, retained for 5 years, as cost-effective as possible.
The correct answer is option D. Configure a cloud storage bucket with an object lifecycle management policy to transition data from the standard class to the cold line class after 30 days.
Why is this correct? D. Standard storage provides low latency for active fraud detection data, last 30 days. Transitioning to cold line after 30 days optimizes costs for quarterly access, every 90 days, while maintaining sub-second retrieval speeds and satisfying the 5-year compliance retention requirement. Why are the others incorrect? A. Keeping all transaction data in standard storage for the full 5-year period is not cost-effective, as data older than 30 days is accessed infrequently and incurs unnecessarily high storage fees. B. BigQuery is an analytical database and is significantly more expensive for long-term raw data storage than cloud storage object lifecycle management, making it suboptimal for simple archival compliance. C. Archive storage is designed for data access less than once per year. Because quarterly reports access data 4 times a year, archive class would incur high retrieval fees, making cold line more cost-effective.
You are architecting a new application feature for a healthcare provider based in Qatar. The feature needs to summarize sensitive patient notes that are submitted by clinicians. A critical requirement is that the content of these patient notes must never be processed outside of Qatar's borders. You want to use a powerful, pre-trained generative model for the summarization task while strictly adhering to the data residency constraint. What should you do? The options are: Option A, write application code that sends the patient notes explicitly to the Gemini API endpoint in Qatar for summarization. Protect the API by VPC service controls. Option B, use Vertex AI Model Garden to select a Gemma model. Deploy this model to a Vertex AI endpoint within a Google Cloud region located in Qatar. Option C, use the Cloud Natural Language API to analyze the text and configure it to generate a summary of the patient notes. Option D, gather a large, anonymized dataset of medical notes. Use Vertex AI training to train a custom summarization model from scratch, deploying it in a Qatar region.
To arrive at the correct answer, we focus on the keywords: summarize sensitive patient notes, must never be processed outside of Qatar's borders, pre-trained generative model, data residency constraint.
The correct answer is option B, use Vertex AI Model Garden to select a Gemma model. Deploy this model to a Vertex AI endpoint within a Google Cloud region located in Qatar.
Why is this correct? B. Deploying an open pre-trained model like Gemma to a Vertex AI endpoint within the Qatar region guarantees that data processing occurs strictly inside Qatar's borders, fulfilling residency requirements using a pre-trained generative model. Why are the others incorrect? A. Managed Gemini API services may process requests on multi-region or global infrastructure and do not guarantee single-region compute isolation strictly within Qatar to satisfy local data residency rules. C. Cloud Natural Language API provides text classification, sentiment, and entity analysis, but lacks generative summarization capabilities needed to summarize complex patient notes. D. Building and training a custom summarization model from scratch is unnecessary and explicitly violates the requirement to leverage a powerful pre-trained generative model.
You are migrating a critical on-premises inventory management application to Google Cloud. The application is a monolith with a traditional relational database, and the immediate business goal is a rapid data center exit. The monolith is exposing an API to other business-critical applications. The long-term vision is to modernize the application into globally distributed, cloud-native services to support the company's expansion. You need to design the initial cloud architecture to ensure that future modernization causes the least possible disruption to other applications that depend on inventory data. The future modernization might require the API to change structure. What should you do? The options are: Option A, use Service Directory to register the monolith's endpoint, allowing dependent applications to look up its address and connect directly. Option B, implement a managed API facade with Apigee to handle all requests from dependent applications on behalf of the monolith's backend. Option C, use an internal load balancer to provide a stable IP for dependent applications to connect directly to the monolith's native API. Option D, provide dependent applications with direct database access by creating secured SQL views on Cloud SQL for them to query.
To arrive at the correct answer, we focus on the keywords: rapid data center exit, exposing an API to other business-critical applications, least possible disruption to other applications, API to change structure.
The correct answer is option B, implement a managed API facade with Apigee to handle all requests from dependent applications on behalf of the monolith's backend.
Why is this correct? B. Apigee acts as an API facade layer that decouples dependent applications from backend changes. It allows API transformation, versioning, and routing, ensuring backend modernization or structural API changes occur without disrupting client applications. Why are the others incorrect? A. Service Directory provides service discovery for endpoint resolution, but it does not abstract or transform API payloads, failing to prevent disruption when the API structure changes. C. An internal load balancer provides traffic routing and IP stability, but it cannot perform API payload transformations or versioning required when API structures change. D. Direct database access via SQL views tightly couples clients to the database schema, creates security risks, and prevents decoupling required for modernizing back-end services.
Your organization uses separate Google Cloud projects for shared services, development, testing, and production. The shared services project hosts your private CI/CD runners and a central artifact registry. The development, testing, and production projects host the GKE clusters where applications are deployed. You need to design an architecture that allows the CI/CD runners to connect to the GKE clusters and the clusters to pull images from artifact registry, all using private IP addresses. However, direct network traffic between the development, testing, and production environments must be strictly prohibited. What should you do? The options are: Option A, create a separate VPC in each of the 4 projects. Connect each environment's VPC to the shared services VPC through VPC network peering. Option B, expose the resources in the shared services project using an external load balancer. Implement a firewall rule to limit access. Option C, create a separate VPC in each project. Use VPC network peering to create a full mesh, connecting every VPC directly to every other VPC. Option D, configure the shared services project as a shared VPC host. Create a single VPC in this host project and attach the environment projects as service projects.
To arrive at the correct answer, we focus on the keywords: separate Google Cloud projects for shared services, development, testing, and production, private IP addresses, direct network traffic between the development, testing, and production environments must be strictly prohibited.
The correct answer is option A, create a separate VPC in each of the 4 projects. Connect each environment's VPC to the shared services VPC through VPC network peering.
Why is this correct? A. Creating a hub-and-spoke model via VPC network peering connects shared services to each environment using private IPs. Since VPC peering is non-transitive, traffic between dev, test, and prod environments cannot transit through shared services, enforcing strict environment isolation. Why are the others incorrect? B. Exposing services through an external load balancer routes traffic over public IP addresses rather than private IP addresses, failing the strict requirement to use private IP connectivity throughout. C. Establishing a full mesh topology directly peers dev, test, and prod VPCs to one another, explicitly enabling direct network traffic between these environments and violating isolation requirements. D. Creating a single VPC in a shared VPC host project allows workloads across service projects to communicate internally by default, failing to enforce strict non-transitive isolation between dev, test, and prod environments.
You are designing the network architecture for a public-facing, containerized web application deployed on Cloud Run. All incoming traffic must be inspected by a Cloud Armor Web Application Firewall, WAF, before reaching the application. You plan to use an application load balancer, which will have the Cloud Armor policy attached. You must ensure that all public requests pass through the load balancer and any attempt to access the Cloud Run service directly through its default star.run.app URL is blocked. What should you do? The options are: Option A, enable Identity-Aware Proxy, IAP, directly on the Cloud Run service to intercept and validate all incoming requests. Option B, create a DNS entry to route traffic to Cloud Armor. Configure Cloud Armor to deny traffic from unknown IP addresses. Option C, set the Cloud Run ingress to allow internal traffic and cloud load balancing, and use a serverless NEG backend on the load balancer. Option D, configure a VPC firewall rule with a high priority to deny all traffic that does not originate from the load balancer.
To arrive at the correct answer, we focus on the keywords: Cloud Run, Cloud Armor Web Application Firewall, WAF, Application Load Balancer. Access the Cloud Run service directly through its default star.run.app URL is blocked.
The correct answer is option C. Set the Cloud Run ingress to allow internal traffic and cloud load balancing, and use a serverless NEG backend on the load balancer.
Why is this correct? C. Setting Cloud Run ingress to internal and cloud load balancing blocks direct public access via the default star.run.app URL while permitting traffic routed through an application load balancer backed by a serverless NEG, ensuring all public requests pass through CloudArmor. Why are the others incorrect? A. Identity-Aware Proxy, IAP, manages user authentication and access control, but it does not restrict network ingress to block direct star.run.app URL access. B. CloudArmor policies attach to load balancer backend services rather than receiving DNS traffic directly, and IP restrictions cannot block direct star.run.app access. D. Cloud Run is a fully managed service outside your VPC by default, so VPC firewall rules cannot inspect or block direct public HTTPS requests to star.run.app endpoints.
To improve governance and security, your organization has structured the Google Cloud environment using folders for different business units. Each business unit folder has subfolders for development, staging, and production environments, which must comply with internal security controls. Production workloads must be protected from direct internet ingress by default unless explicitly tagged. The application must be accessible to customers over HTTPS. You need to design a scalable and enforceable model that blocks internet ingress traffic to the production folders while selectively allowing direct HTTPS traffic to the necessary virtual machines. You must also ensure that individual project teams cannot overwrite these controls once they are implemented for all current and future production projects. What should you do? The options are: Option A. At each production folder, apply a hierarchical firewall policy to deny all ingress except for HTTPS to tagged VMs. Option B. Mandate the application teams to deploy a Terraform module to create VPC firewall rules in each project that deny ingress and allow HTTPS. Option C. At the organization root, apply a hierarchical firewall policy to deny all ingress except for HTTPS to tagged VMs. Option D. At each production folder, use an organization policy to block all external IPs and require teams to use external HTTPS load balancers.
To arrive at the correct answer, we focus on the keywords, folders for different business units, protected from direct internet ingress by default unless explicitly tagged, selectively allowing direct HTTPS traffic, cannot overwrite these controls.
The correct answer is option A. At each production folder, apply a hierarchical firewall policy to deny all ingress except for HTTPS to tagged VMs.
Why is this correct? A. Hierarchical firewall policies applied at the production folder level enforce non-overridable firewall rules across all child projects, automatically applying default ingress deny rules while allowing HTTPS traffic to VMs with specific secure tags across current and future production workloads. Why are the others incorrect? B. VPC firewall rules created at the project level can be modified or deleted by individual project teams with project admin permissions, failing the requirement for non-overridable, centralized control. C. Applying the policy at the organization root would restrict ingress across all environments, including development and staging subfolders, rather than targeting only production folders as required. D. Organization policies cannot selectively allow traffic based on VM tags, nor do they support rule-based ingress filtering for direct HTTPS traffic to specific virtual machines.